So welcome back. We are looking at the circuits that have dependent sources, and we try to solve them using the nodal analysis. So the next example for this series is that we have this circuit. So in this circuit we have again a dependent current source, okay, which is basically 2 times of I naught, and I naught is the current that is flowing through this resistive branch of 10 kilo ohm. So we need to use the nodal analysis to find all the voltages, which is basically V1 and V2 here, and the current I naught. So the nodes of this circuit has been labeled as V1 and V2. Okay, there are two nodes and the third one is reference node here. So let's try to write the equation for the V1 here. So what will be the equation for V1? All currents are leaving. So this current is leaving, this current is leaving, and this current is leaving. So current through 10 kilo. So that will be what? V1 minus 0 divided by 10k, which is basically our I naught. And then this current is leaving 4 milliamperes. I will put minus 4 milli. Then the current through this till 10 kilo. So that will be V1 minus V2 divided by 10k is equal to 0. So this is the equation for the first node. Let's write the equation for the second node. So what will be the equation for this node now? All currents are leaving from this node. So in this case, we can say that we have this current through 10 kilo leaving, this current leaving, and this current leaving. So current through this 10 kilo, that will be V2 minus V1 divided by 10k, okay, this current. Then this current, okay, that is also leaving, so 2 times of I naught. I put plus because the direction of the leaving is same, okay, the dependent current source here. Then the current through this 10 kilo, so that will be V2 minus second node. Okay, what is the second node here? Ground, 0. So V2 minus 0 divided by 10k is equal to 0. So we have two equations but with the three unknowns. So why three unknowns? Because we have a dependent current source with the control variable I naught. So what is the control variable equation here? Current through 10 kilo ohm. So what is that current? I naught is basically what? This voltage minus this voltage, right? What is this voltage? V1. So V1 minus 0 divided by 10k, or V1 divided by 10k. Okay, so this is our control variable equation. We can put that in our original equation to get the only equation with the variables V1 and V2. So let's do that. So V2 minus V1 divided by 10k, 2 times of I naught. What is I naught? We just found that this is basically V1 over 10k. Then V2 minus 0, I can rewrite this as V2 over 10k is equal to 0. So let's simplify this one. How we can simplify? Multiply with the 10k here. Okay, we can use the biggest values in the denominator, okay, lowest common multiple of the denominator values. So if you multiply with 10k, what will happen? 10k will be cancelled. So I have V2 minus V1, then this 2 times of V1, then this V2 is equal to 0. Let's rearrange it. Minus V1 to V1, that will become V1. V2, that will become 2 times of V2 is equal to 0. So we have our first equation for the node 2 in the simplified form. Let's label this as equation 2. Let's come here. So again, what we can do here? We can multiply with the 10k here. So multiply with 10k cancelled. So I have V1. Then minus 4 multiply with 10k. What will I get? Minus 40. Milli and kilo will be cancelled. Then plus again V1. 10k is already cancelled. Minus V2 is equal to 0. Let's rearrange it. V1, that will give me 2 times of V1 minus V2 is equal to 40. Okay, so again, two simplified equation. Use the method substitution, Gaussian matrix, or scientific calculators. You can use whatever you like, and we try to get the values of V1 and V2. So simplest way, again, like we use, let's use the substitution. Let's get V1. Again, I get V1 or V2 from this equation or the other equation, whatever we like. So V1 basically will be 40 plus V2 the whole divided by 2. Okay, like we can take v2 to the other side, so that will become 40 plus v2, then divided by 2. Let's put that in the second equation. So what will give me this? Okay, so this equation is basically what? Let's put it here. So v1 become 40 plus v2 divided by 2 plus 2 times of v2 is equal to 0. So let's simplify. 40 divided by 2, 20. Then 1 over 2, that will be 0 0.5 of v2 plus 2 times of v2 is equal to 0. So 0 0.5 v2 plus 2 v2, that will give me 2.5 v2. So v2 basically is equal to minus 20 divided by 2.5. So what is the answer? Like if you have 20 divided by 2.5, that will give me basically minus 8 volt. Okay, so this is the value for the v2. Let's use this value to get the value of v1. Okay, so we can put that back here in this equation. So let's simplify this one. So what will be that? 40 plus v2. What is v2? Minus 8. So 40 minus 8 divided by 2. So what is 40 minus 8? 32. 32 divided by 2, 16 volt. Okay, so we have found our both node voltages. V1 comes out to be 16 volt and V2 comes out to be minus 8 volt. Okay, so this way we can find all the nodal voltages. So we have found the nodal voltages and the current I naught. So we have already know what is basically current I naught, our control variable V1 over 10k. So we can put up the values that we have found here to find the value of I naught. Okay, so V1, what is V naught? 16. So 16 divided by 10k. Okay, so that will give me the value of I naught. Okay, so what will be this value? Simply 1.6, right? 16 divided by 10, that will give me just 1.6, and k will be changed to milli. So 1.6 milliampere. So we have found all the nodal voltages, okay, and the current I naught. Thank you so much.